Okay, now let's continue our review for the Unit 1 exam in astronomy, and now we're going to talk about where do the electrons live inside the atom. So this is really the most important thing in chemistry, this idea of where the electrons live, because that in turn is going to determine the reactivity of that particular atom. So this is very important stuff. And they have determined that an atom has a nucleus, which is in the middle, and then surrounding it are going to be energy levels, which I'm going to represent as being floors of an apartment building. So that you have the first energy level, which is going to be the ground floor of the apartment building. And then above it is going to be another energy level, which has more energy. And then above that is another energy level. So the lowest energy level is down here, and then it gets progressively higher with more energy levels. Now, in terms of the nucleus, if this is the nucleus of an atom, then the first energy level is going to be represented by a certain distance away from the nucleus where electrons can live, and then the second floor is going to be another energy level which is going to be further away from the nucleus, like that. But let's continue talking about this one up here, this way of looking at it. So on the first energy level of the atom, there is room for only 2 electrons. So only 2 electrons can live on the first energy level. When you go to the second energy level, it turns out that there are 2 rooms. So there is 1 room on the first floor. When you go to the second floor, there's going to be 2 rooms. And the first room over here is going to be identical to this room here. So 2 electrons can live in this room, but there's another room over here that can hold 6 electrons. Now, for us, that's as far as we need to go. So this isn't chemistry, so I just want you to recognize the rooms that can hold 2 electrons, which are going to be called s subshells or s orbitals. And then that means that this one is also an s, and this one over here is going to be called a p subshell or a p orbital. So just remember that s's hold 2, p's hold 6. That's all that you need to know. But in chemistry, you would also learn about some of the other rooms, such as the d and the f subshells, but we don't care about those. Now, I know that you're saying, why 2, why 6? It comes out of quantum mechanics. So quantum mechanics is a mathematical way of viewing how very, very small objects operate. And atoms are small, so we have to use quantum mechanics in order to describe how an atom works. And so these numbers are generated through quantum mechanics. So having said that, don't worry about it. So you just need to know the numbers, not where the numbers are actually coming from. So the idea is now going to be to explain the periodic table of elements. I'm going to give you that on the exam. You just need to know how to read it. Okay? Now, there are 2 sets of numbers on the periodic table. A number that doesn't have a decimal point and a number that does. Forget about the numbers that have decimal points. We don't care about them in this class. In chemistry, oh yeah, so big time in chemistry. So I'm only concerned about the ones that don't have the decimal points. Those are the atomic numbers. Those are the numbers of protons in the nucleus. So if we go back to here, find 1, that corresponds to hydrogen. So every hydrogen in the known universe has one proton in its nucleus. Okay, now find 2. So 2 corresponds to helium. So every helium in the known universe only has 2 protons in its nucleus. Now you might be wondering, well, what about the number that has the decimal point? That is the atomic mass. That includes the effects of the neutrons in the nucleus. So the combination of the protons plus the neutrons gives you the atomic mass. Now you can forget it. Let it ooze out of your head. There it goes. Not going to be on the exam. Now you do need to know what an ion is. So let's say, for example, that this thing had 2 protons and then it had 2 neutrons in its nucleus. If it was electrically neutral, it should also have 2 electrons. So let's put an electron over here and an electron over here. And both of these are negative, and they're balancing the 2 positive protons. So that this particular atom, which would be helium, would be electrically neutral. Now let's say that you heat it, or you hit it, or you do something chemically to it so that one of these electrons is knocked out. So that electron goes flying away. What have you got? Well, it's still positive 2, but now it's negative 1. So that means that overall, this thing is going to have a positive net electrical charge. So we would say that this thing is helium, and then we're going to put a plus symbol to represent the fact that it is a positive ion. It's been ionized. Got to know what an ion is. Now, what would it mean if it was a negative helium? Then it would have a net negative charge, which would mean that it had an extra electron in orbit. Well, actually, we need to put it up here. But the point is, you'd have to have an extra electron in there in order to do that. Okay, now we're going to take an empty hotel and we're going to start to put electrons into it. We're going to have 2 rules. Rule number 1, electrons go as low as possible. So if I hold my hand here and I drop the pen, it goes down that far. But if I take and I hold it over here and I drop it, it goes all the way down to there. So electrons always want to go as low as possible into the atom. The other rule that we're going to have is they prefer to go into the s orbital, the one that holds the 2, before they go into the p. So let's try it. We're going to take 1 electron, we're going to drop it in. Where does it go? It goes down to the bottom floor to live. So that is going to be hydrogen in the first column. Okay, then we're going to take 2 electrons and drop them in there. So the first electron is going to go into the S. The second electron goes into the S because it can hold 2. And then the third one, it cannot go into the S down here because it's full up. So that third one has to go up here. And it starts to fill in this one first because it would rather go into the S than to go into the P. So it's going to start to fill up this room first. But now let's say, for example, that we're talking about carbon. So carbon has 6 electrons. Okay, 2 of them are going to go here. Okay, now that leaves us with 4. 2 more are going to go over here. So that still leaves us with 2 more. So the last 2 electrons are going to go into this one over here. Okay? So that's where the electrons are going to live in those particular atoms. Okay, now let's talk about a tiny bit of chemistry. So I don't want to overwhelm you with chemistry in an astronomy course, but this is really important. So in an apartment building, you've got fire doors, and the purpose of a fire door is to keep a fire from spreading. So it keeps a fire on the first floor from getting to the second floor. We're going to have a rule that says once a floor of the atomic apartment building has its maximum number of electrons, the fire doors are going to close. And it's going to seal off this floor so that these electrons will not participate in a chemical reaction. They're sealed off. All right, so let's look at lithium. Lithium has 3 electrons. So 2 of them live here, but it's got 3. So the third one goes up here. All right, that means that the fire doors close, and that means it has 1 outer electron. Another name for this is 1 valence electron. So the valence electrons, the outer electrons, are the ones that participate in chemical reactions. Okay. So you might be saying, well, this is too hard. I can't remember how many valence electrons these things are going to have. Well, it's very easy. You just look at what column in the periodic table the atom is. So if the atom is in column number 1, it has 1 valence electron. If it's in column 2, it's got 2 valence electrons, 2 outer electrons. If it's in column 3, it's got 3 valence electrons. Okay? Now you might be looking at that picture and you're saying, well, what about the yellow part? Well, don't worry about it. So that's chemistry. So if you take a chemistry course, you would learn about those particular atoms in there. They're kind of strange. So we're not going to worry about it. So I'm only interested in columns 1, 2, and then over to column 8. And so whatever column the atom is in, that's the outermost electrons it has. Now you're saying, oh, who cares? Okay, I'm getting to it. So the next thing is magic numbers. So according to quantum mechanics, so I can't explain it, I'm just telling you, according to quantum mechanics, there are certain numbers of electrons that atoms like. And one of those combinations is the number 8. Atoms like to have 8 electrons in their outermost shell. So they like to have 8 valence electrons. Now, how do you get the number 8? Well, it could be 4 plus 4. It could be 1 plus 7, but 2 plus 6 gives you the number 8. And look at this. You've got 2 columns on this side over here, and you got 6 columns on this side over here, and when you add 2 plus 6, you get 8. So that a very, very stable atom is going to have 8 outer electrons. So where's that at? So if you look at where's the number 8? It's in that very last column. Those are called the noble gases. So helium, He, is a noble gas. It has achieved this number 8, but now you're saying, but it only has 2 electrons. Well, another magic number is 2 for helium. Don't worry about it, okay? So don't worry about it. So it's in that first column. If you strike a match and you hold it up to helium, nothing happens. It's completely unreactive because it has achieved its magic number. Okay, if you look at the one that is underneath it, then you have neon. Okay, and neon is also very stable. Okay, so any element in that first or that last column over there, the one that's over here, is going to be chemically unreactive. Well, what about other elements? So let's take a look at sodium. Okay, so sodium is going to be in column 1. It's over on this side of the periodic table. It's in column 1, so how many valence electrons? 1. Okay, and so it wants to get to 8. So it could give away 1 electron or it could grab 7. It turns out it's very easy for sodium to get rid of that 1 electron. It's highly reactive. So you saw the video in what happens when you put sodium into water. It explodes. Very reactive. Chlorine, okay, it is on this side of the periodic table right next to column 8. It's in column 7. It wants 8. It's highly reactive. So the closer the valence number gets to either 0 or 8, the more reactive the element is going to be. And then we found out that if you take the sodium and the chlorine, and they're both very dangerous when they're by themselves, but you put them together, then an electron from sodium is transferred to chlorine. They both become ions. Opposites attract, and so we've just made sodium chloride, which again is very happy. So that's a stable chemical that is created in this chemical reaction. Okay, let's take a break. And when we come back, we're going to talk about how do you give energy to atoms and how do atoms give off energy.